When we speak about gene expression, is the activity of the DNA. So the genes that are printed, written in the book that is our DNA, are always producing material that is translated in protein, so in reality. And this activity of the gene is like a symphony. So it's more than a noise. They are waves of activity. And many genes are constitutional. I mean, they are always expressed. Are genes that are building our architecture. Many other genes are going up and down in response to the environment. These genes are the mechanisms that we have to interact with the environment. And this is the secret of life, because there is no way to survive if we are not able to change our metabolism every second. So the second part of nutrigenomics is how to interfere with this symphony. So how to enter in the symphony, activating some genes or downregulating some other genes. To explain the incredible potential of this branch of the science, I've chosen the most complicated situation in life, because it's probably the most unknown, and it's quite frightening. I mean, everybody has inside some problems with this idea. There's also there is a sense to speak about aging, because aging is the phenomenon. Because in one way, this is a workshop linked to an anti-aging conference, so give more sense to everything. Well, so first I have to introduce the biological problem. Then I'll show you how nutrigenomics can interfere with the aging process. And we have to keep in mind, anyway, that the 90% of the disease that we have in the Western world are related to aging processes. So it's a degeneration of aging, is a pathological aging, but are chronic disease, multigenic, with a complex etiology that are typically of the last part of our life. Cardiovascular disease, cancer, neurodegenerative disorders, and so on. So there are many ways to give an idea of the longevity of a population. Probably this is not the best picture, but is... It's okay?
Put your power back in. Your electric back in.
Ah, okay. Otherwise... okay. So this is a projection of the number of centenarians in the US. It started the projection in 2000 till 2050. And as you can see, is a classical picture of the trend of the improvement of longevity in a Western country. So these are the number of centenarians. The other side of the coin is well known, and I've chosen my field of research, the field where I used to work, that is Alzheimer's disease. This is a projection of the number of Alzheimer's disease patients. Started a little bit early, the analysis, but will finish in the same period, 2050. As you can see, the trend is overlapping. This data came out from a research done by Alzheimer's Disease Association in 2001. Alzheimer's Association did the annual meeting 1 month ago in Washington, D.C. They presented the new projection, and there was an incredible underestimate of the number of the patients. There is a little bit improvement in the last 20 years in the USA, but what they haven't seen, and of course it's not in this diagram, is the incredible improvement of the disease in Asia, mostly in China. they are speaking about a triplication of the number of cases in the next 20 years. So it's a real epidemic. So it's more than a small problem. It's something that can affect the health economy in an incredible way. So I've been invited 2 years ago to a very nice congress organized in Melbourne by it's an association dedicated to preventive medicine, but financed by OMS from the WHO in English, the World Health Organization in Geneva. The vice president of WHO is the president of this group in Australia, and they presented their projection about the ability of government to sustain a population that is old and sick. And in 2050, there will be the bankrupt of many of the European systems. I'm not speaking about the United States, where the health system is a little bit more complicated, but also for them it will be a big problem to maintain this situation. So this gives a great sense, politically, not only from a medical point of view, to improve research in the field of preventive medicine. And in this field, nutrigenomics is one of the more promising branch of the medicine. As you can see, probably many of you know this lady. The two pictures are strictly linked with the diagrams. No, this is the famous yes. Centenarian in the world, the French lady, yeah, Jean Calment. Jean Calment, she maintained the Guinness of. She died 122 in 1997. Of course, the problem is not to reach that kind of age. Recently, there was a lady in Ecuador, I think, or in Bolivia. She died at she claimed before dying, no, the parent, not after that, to have 128, but was not probably not serious. I mean, there is a lot of confusion about the real birth date. I will go on there is a special place in Sardinia, near Ogliastra, where there is a very high number of centenarians, and is a unique case in the world, because it's the only place where males are more than women. Yeah. So it's the only case of male longevity. Anyway. And here you can see a classical brain of an Alzheimer patient, just to let you know that this is a tsunami that happens inside the brain. So nobody knows why. So there are many clues, many polymorphisms, many SNPs, many situations that can improve the risk. But the reality is that at the moment nobody knows why it happens. But when it happens, it's very difficult to block. It's like a wave that destroys at the end completely the brain from the inside. So you are not just losing function, but you are losing material. I mean, flesh. Well, fat in this case. So, coming back to the first question. This is the major question of science, right? So, and I have to say that there are so many hypotheses, so many theories, but nobody can give a simple answer to this. Neither me, I mean, so I'm sorry, but I can give you a very fast, very quick picture of the major theories and what is the state of the art in terms of the possibility to give a real explanation of the biological mechanism of aging.